Okay, so we are looking at graphing the solution to the following system of inequalities and kind of looking at what we're given. We actually have 4 inequalities. And we've kind of played around with some techniques already. But the first thing you'd like to do with graphing these, I like to do them separately. So I'll look at graphing this first line. I recognize it as a line because there are no squared variables. And then understanding the shading for that. Then I will do the second line, understand the shading for that. Then the third line, understand the shading for that. And the fourth line. I don't really have a pink marker. Let me see if I can, I'm trying to make it consistent with the, what do you call it, inequality. Oh, there's a magenta, I'll go with that. There we go. Let me change that. So a little bit thinner. Okay, so at least we do have some consistency with our TI. Okay, so let's start off with x plus 3y less than or equal to 6. Right now, if I'm looking at graphing the boundary line, x plus 3y equals 6, I'll solve it for y. So I'll subtract x on both sides. I have negative x plus 6. I'll divide every term by 3. So now I get y equals negative 1/3 x plus 2. So I kind of like my lines. It's a little faster for me to graph if it's in slope-intercept form. Remember, y equals mx plus b. So this kind of tells us that the slope is negative 1/3 and the y-intercept is at 0, 2. So if I'm going to graph it, I'll start at 2 and I'll use the slope to get to the next point on the line. So that tells me to go down 1, right 3. And I can keep going if I want to be consistent or if I don't have a straight edge. Down 1, right 3. Down 1, right 3, and so on. So we do have our line. And if you're going to connect it, what we'd be looking at is using a solid line because of the inequality symbol. So I'll see if I can, the best I can. I do have a somewhat solid line. Now, next step is to decide what your shading would be. Should we be shading above the line or below the line? And I'll use a test point just to help me out. So I shall test my favorite point, which is 0, 0, because I know the line doesn't go through it. So if I do that, I have 0 plus 3 times 0. Is that less than or equal to 6? So is 0 less than or equal to 6? It is true. So 0, 0 is located below the line. So the shading for this line would shade below. So I like to do this first. If I shade as I go, I won't get so confused with all of the markings that I'm going to make on my paper. Okay, next line. We're looking at 5 plus 2y is less than 10. Less than or equal to 10. And same story. I do know that it is going to be a solid line based on the inequality symbol. I can solve it for y. If you want to rewrite it so it's easier for you to say with boundary curves, I replace the inequality symbol with an equal sign. Solving for y, I subtract 5 from both sides. So I have negative 5, There's a 5x plus 2y, right? There we go. I knew something was a little bit weird. So again, solving for 2y, we are subtracting 5x from both sides. So we have negative 5x plus 10. Divide both sides by 2, every term. So we get y equals negative 5 halves x plus 5. Let's make that a little prettier. So if we're going to graph it, our slope is negative 5 halves, and our y-intercept is at 0, 5. So we'll start at 5. 1, 2, 3, 4, 5. There's our y-intercept. And we'll be going down 5 and right 2. So down 5, 1, 2, 3, 4, 5, right 2. I'll do this again. 1, 2, 3, 4, 5, and right 2, and I got more of an accuracy going. Feel free to keep going if you need more, but we're going to use a solid line to connect our points. And now we have to ignore the other markings on the paper. So ignore what you see in blue, and then you just kind of understand there's two regions. You're either going to shade below or above the line. And we can continue to use our test point because that red line does not go through our test point. So I can test again, 0, 0. And if I do that, I'm kind of looking at 5 times 0 plus 2 times 0, is that less than or equal to 10? And you're saying, well, 0 is less than or equal to 10. That is true. So if that is the case, we're going to shade this region containing our test point. So that means we will shade below. So what I'm looking at, if I'm shading below, using hash marks to help me out. And as this gets a little more complicated, you want to take track or keep track of what areas are you shading twice. So right now, I kind of see that I have a region that starts maybe about here and here. It looks like that's the region I'll be focusing on when I draw my other lines and my shadings. So let's continue on. We have x is greater than or equal to -2. And that one's kind of nice. If you're shading the boundary or making the boundary curve, x equals -2. We have ourselves a vertical line. And it's crossing through x equals -2. So if I'm going to draw that, keeping in mind, it will be also a solid line again. So x equals -2. Kind of have shading. I do have right here. I do have a solid line. Now, if you'd like to use a test point, you can, but you could also use the idea of directional. If you are shading x is greater than -2, all the numbers greater than -2 would mean that we shade to the right. If you'd like to use a test point, feel free. So if I'm going to shade to the right, kind of see it's getting messy, huh? Now I just want to make sure, as you're shading, kind of keep track of what you originally had overlapping. We had this region, kind of. And then now that we have the x value, we still have, just kind of keeping track here, we still have everything to the right of x equals -2. So what I see as I'm going is I see here, here, and here to narrow down my focus. So we're almost there. I'm going to erase that because I want to make sure that you can view it. Or if you want me to leave it, I don't mind. Sure, I'll do that. Okay, so I'm not quite done yet. One last line. Y is greater than there it is. Y is greater than -4. Greater than or equal to -4. Okay, so this will be for drawing our boundary curve or boundary line. Y equals -4. We have our horizontal line crossing at y equals -4, and again, it's solid. So y equals -4. I've got to really go back and look at where my axes are. 1, 2, 3, 4. So you have a solid curve, or a solid line. And y is greater than -4 means all the numbers that are bigger than -4, we will be shading above our boundary line. So now we have a lot more shading. And I'm realizing, it is looking pretty scary here. So this is what we have to do for ourselves. We have to really focus on where have we colored. And we're looking for the intersection of all the shadings. We can't just leave this mess for our final solution. So what this would leave us with is really paying close attention to seeing. First off, I believe we are looking at, it's kind of like a trapezoidal region. So everything to the right of x equals a -2, everything above y equals -4, and everything overlapping with the blue and the red. So it's kind of like a trapezoidal region. So you would have to either highlight it or you have to like be able to point to it, and it's going to be a little difficult here. But that would be our solution. Oops, we should probably label it. That would be good for us. Let's do that. Have our solution. For ourselves. Wonderful. Now, if you're checking your answers, you will not see all this scribbling in the back of the book. What they tend to do is they only show where the shading is located. Along with the boundary curves. So if I can do this one more time, just so you can see a clear idea of what the solution would look like. I'm going to graph this one more time. 1/3 x plus 2 down 1/3. Okay, so they might show the curves. We have 5/2 x plus 5. Down 5/2. There we go. Oops, I need to draw the 5 first. Okay. So maybe you get a cleaner idea. There we go. And then x is greater than -2. That wasn't quite straight. I'll try harder. And y is greater than -4. So now what's kind of cool is you have a much better idea of what the solution looks like with all the mess going on around. And it's really cool that, yeah, they can make the solution and show you in the back of the textbook, but they don't know the solution unless they do all of the steps that we did today. So they just took out all the mess, but it does take a little bit of time. So I encourage you to be patient with yourself. We could also try this on the TI and see if we're interested to kind of tell, do we get the same idea? I encourage you to play with maybe the Inequalities app if you'd like, but I kind of prefer with all of these, I think it's a lot less trouble if we try to do this by hand, because in the long run, you still have to know what the shading is going to look like before you program it into the TI. So feel free to play. Like I said, practice these a little bit more. I'm sure you'll do fine. But I hope this helps, and I will see you in the next example.